Hello, and welcome back, everybody. Long time no see. So, it was like a lot of experiments during this week when I was offline. So mostly of these experiments was related to the operating systems and like all of the stuff related to them. I tried to, try to install everything I just wanted to try, like Ubuntu, Pop! OS, various Arch Linux distros, except of Manjaro, because Manjaro is, full of even Windows, I tried to switch like entirely on Windows. I thought that Windows is Windows WSL2 is like somehow good replacement for the for the old Linux ecosystem, might be like but just so WSL, I think it's good for somehow for the like front-end developers, but still this is not an like bare metal Linux, and basically you can't use you can use a graphical applications like Node via the OpenRTP protocol, but so performance is like worse experience, which happened with me with WSL2 and Windows. Yeah, so it's like, it's this taste when you like working in Linux, but everything around you is Windows. It's like this bad taste when you're like tasting like something is going not correctly, so something is going wrong. And also even they have this super cool terminal called Windows Terminal. It has, like, as you may see, 88,000 stars on GitHub, but still it's like full of shit, because even these icons can be displayed correctly in this terminal. They are somehow like too small and not colored, and I like tried to install preview versions of the Windows terminal, and still it's like lacks of a lot of features which like freely available on Linux. And the main problem for me was that you can't basically use all Linux environment inside this WSL2. So you still have limitations, but you don't have limitations of so there are a lot of like they promotion cool features, like you can use graphic hardware acceleration and like so on, but all of these features are available under the preview versions, and a lot of them are just just pass through to the Windows, and still you might be required some Windows drivers and etc. So, and still you would have very Windows issues when you if you try, like, for example, to have an access to like Windows from Linux, from Windows subsystem for Linux. So you may expect a lot of like permissions issues which comes to your Linux distro. So it's not, so this is as they described, this is Hyper-V, teeny layer between like a Windows machine and Linux, and this is still not not a like true Linux experience, is if I like can say like this. I just tried to, but the most important thing, that super cool guys from the OpenSource GoXLR utility created this GoXLR utility. I tried it, I guess like a few months ago, and so unfortunately my devices won't work with it, but they released new version, and surprisingly, GoXLR works without any problems on Linux. So I have my profiles, I have my channels. So basically, so as you may see here, pulse audio, and I have so basically everything. For the input devices, I can control broadcast. I can like reroute the devices, the sound. I can like for the recording, I can assign specific channels on specific applications. For example, if I wanted to path to route music through the only some kind of for example, like this, like Spotify, I want to route it through this channel, GoXLR Mini Music, so you are free to do this. And I found interesting fact that on Windows, this is far more complicated to achieve. So you should install drivers for sure. This is fairly easy, for all. And then you have to like reroute your like sound tracks and to the different channels, and this is way harder to do inside Windows. I found this because you need to find this configuration options. You need to like dig like very deep into the sound configuration, found sound properties, and then like having like 10 devices, like choose needed ones. So it's like but good things from Windows, and which I'm waiting, which comes to Linux, called NVIDIA Broadcast. NVIDIA Broadcast, and it's available only for the. Oh, this is something new. Like just year ago. So it's only available for Windows nowadays, and it brings to you, for example, if you wanted to remove your background without placing a green screen behind you, so you can do this with NVIDIA Broadcast and like reroute your camera output to this NVIDIA Broadcast application. And this is super cool, and this is unfortunately available only on Linux. I'm sorry, on Windows. It would be super cool if it would be available only for Linux, but not for Windows. I wish I could upload twice. Yeah. So what is the end? Seems it's currently in development. Yeah, so I already requested an access, so by invitations only. So I have an NVIDIA account, and I like tried to join, but still have nothing. But so it's only video effects SDK. It's not. So there are three things which are available under Windows. So it's like NVIDIA Broadcast itself. Then video effects SDK and audio effects SDK, which can like use super artificial intelligent things to remove like background noise or keyboard, something like this. Yeah. So and my my adventure with Windows is ended, and I came back to good old i3, which is like super cool to have, and it's like works like a charm. Okay, so I also first I should close it. I didn't. So during all of this time, when I switched to like I don't know, with one moment I switched from IDE to NeoVim. During all of this period, I never tried to back on IDE, like to move back on IDE. So I never thought about this to like move back and return my IDE setup and like etc. So because I think moving to NeoVim and like having all of this setup is best decision of 2023 for me nowadays. So it's like I'm super excited to use it. I even moved all of my. So I paid, I guess, for 5 years in a row for JetBrains products. I guess it was like $250 US per year, and now I like just just sponsoring with all of this money NeoVim. So just the same, I'm just switched, but support NeoVim guys to bring this product way better. Okay, guys, so what we're going to do today. Unfortunately, I tried also to let me Excalibur. I also tried to so I also tried to implement this Navia tool, which is I remember you implementation on with the WASM implementation of RoadRunner monitoring tool. And the problem with this tool is that protobuf actually where is it? GitHub, run Navia. Do we have this? Yeah. So problem that you can't compile it. So if you have an application, let's see, this is our Navia tool. And you try to compile it with WASM, and you have here inside, for example, protobuf. So it's not implemented yet. WASM is not implemented yet for the protobuf, so it won't play together. Like WASM and protobuf won't play together, and the application simply won't compile. So I don't know how. I don't know how to bring all of this functionality without WASM. For sure we can create like a classical application when we have like UI written in some fancy modern JavaScript framework and plus backend, but it's not super fancy to do. I think I would rather wait for like protobuf implementation in WASM to bring everything inside one WASMed application, rather than going to use this classic scheme of implementing the application. Or I don't know, so I need to decide about this, because I don't want to bring my hands into this like front end shit. I'm sorry, because I know nothing about this part, especially like nothing. Yeah, and what we're going to do today. So let's bring us to the topic. So we have this ticket. To fork. So this is kind of old one. It's like almost a year ago was issued to our bug tracker, like issue tracker on GitHub. So basically, what is about? This ticket is about having. Let me show it to do better, to show it like graphically. So now we have workers nowadays. All of them are PHP CLI applications. Problem of this approach is that we are forking and creating the workers from the Go application. We are like have a command cmd, which like PHP, like some file PHP, and we are starting these workers. The problem of this approach, first of all, advantages of this approach is that you can easily control your children's, like, because it's like your processes, your children's, so without any problems you can control them. But down like, I don't know, minus of the things that you would have a lot of memory. You spend a lot of memory on this, like 26 megabytes per worker. This is like a base consumption. So 26 megabytes just to start a worker. It's like empty worker. And if you have like real application, it could be up to like 100 up to 500 megabytes. And then imagine that you have like some kind of 10 workers. So it's like 5 gigs of memory allocated by the RoadRunner with easy. So yeah, I know this is PHP, and this is like, you can't basically avoid allocating this because you're not controlling. But if we introduce this, the like updated approach, if we would have Go application, we would have master, let's say, worker, and we will send a command like to fork. Please fork yourself. So, and when worker fork itself, it will create a shared memory object. Yeah. So all of them are pointing to the same memory. It's like copy on write technique. So when some process like let's say worker 1, worker 2, worker 3, boom, boom, fork. So all of them are pointing to the same memory. So this is virtual, I'm sorry, let's say virtual memory. And when some of this process tries to write something into some particular cell in this memory, it like writes in its own copy. So, but if you read only, like you processes like access some memory structures, for the read only, they all can share this memory region. And the next advantage is that all of these processes might share op cache. So since we have op cache, so all of them can share the single instance of the op cache. So imagine a case. Worker 1, worker 2, worker 3 are started. And then they like start to work, like working, and worker number 2 dies. Like boom, do we have this colors? Oh, yeah, we have. And worker 2 dies. Boom, dead. In the first approach, if worker dies, we reallocate it with easy reallocate worker. And it have empty op cache, you know? Op cache is empty. So it's so hard to write with mouse. So it's empty. And this op cache is per process. Like this one and this one also have their instances of op cache. But since we have like single instance for the op cache for all of these childs here, we just recreating the link. So it's like done automatically by PHP because we just fork and create another instance pointing to the same op cache memory address, and all of the work which was previously done by this worker is already in the op cache. So you can start super fast. So seems like looks super cool. Yeah, you know, so it looks pretty awesome to implement and to have this. Let me. Yeah. Needed to answer. And so super cool approach here is that, yeah, you can reduce memory consumption for sure. And I started to implement this like and as you may see here, oh my god, so bright. Let's let it be like this. So here you may see 22 megs per master process. Like it allocates 22 megabytes and like have all of this memory allocated by this only one worker. And all forks allocate only 8.6, like it's like 3 times less memory than the master process. if we start like bombarding the workers with requests, the memory consumption can be like 10 megs, can rise to 10 megabytes, like something like this, but no more. This is twice as less as like master process. And then imagine a case. Then you have like worker, master worker. This is our master worker, which costs you. So this is like it's not I don't know how to say, it's not handling all of your application. It's only like designed to fork itself, only to fork itself. It's not running the whole your application. So it's, I expect it's not to be done like to run, like to have I don't know, to run a whole your application to have a big memory consumption. So this worker is designed to be super small. So let's imagine it have like 20 megabytes consumption. And in previous generation, workers have like 500 megabytes. But now, if we reduce it 3 times, it would be 100 and let's say 15 and 150 megabytes per each. So this is kind of, you know, impressive to have inside application. Let's bring to the problems. So what was the problems implementing this? The first and most significant problem was that you can't, so if you have a parent, yeah, parent process, and you have a child, so you can basically wait it with the waitPid system call without any problems. You can wait until it dies, and after it dies, you can just reallocate it or do whatever you want. If you have this scheme, let's say updated scheme, like this is parent, this is master worker, and then this is child, then in this scheme you can't control this child, because child of your child is not your child. So this is like I know, basic rule of the relationships. So you can't wait this child with waitPid system call. So waitPid is not applicable here. So you can't do like this. And so the main problem that in the Linux 5.10 was new system call was introduced, and this system call called like syscall pidfd open. Pidfd open. So basically this system call, where is it? It's not, yeah, system call sysfd open. Yeah, so this system call just opens a file descriptor and waits on it. So the, where is it? It was, yeah, non-blocking. So it was introduced in Linux 5.10. So the minimum requirement for this non-blocking wait is 5.10 for us. Yeah. And it first appeared in 5.3. So this is kind of, you know, for the enterprise is rather new kernel than old. And let's see a Linux kernel releases. So currently we have like 5.4, you know, 5.3 is not LTS, and it was like 5.10 is LTS, and it was released in 2020, so 2021 almost. So this is kind of, you know, kind of new kernel, and it will be supported to 2026. So okay, so this is good requirements for us to start. So I also wrote this small program like to have a blocking wait, as you may see here. So wait for exit, so it blocks until the process exits. what we need to do now. So what is the architecture of all of this stuff? Let me... So we have a pool of workers. Yeah, this is this is Go. This is PHP. So on the Go side, we have a pool of workers. Worker, and worker. All of these workers, which actually processes, waits until they stopped. Waits for like different conditions, like script can die, script can, like, I don't know, something might happen with this script, PHP script, I mean. So, and this workspace might die, so we have to wait. So we have to use waitPit. waitPit. So waitPit would be replaced with sysfd open. Sysfd open system call. So, and it would be available only for the Linux 5.10 and more. So all of the, like, old behavior, all good behavior will still be existed until we test all of the things. And yeah, in new architecture, we are going to introduce, how can I move this? Can I move? Oh yeah, I can. So in new architecture, we need to introduce a new worker called master worker and do all allocation stuff only with master worker. So we need to send a data only, like, please give me the fork, and worker with pcntl fork. So unfortunately, there's no such functionality for Windows, so Windows users, unfortunately, as usual, sucks in this case. So we have this pcntl only on Linux. I think we also have a Mac, but I'm not sure. So since Mac is like somehow POSIX compatible, so it should exist on Mac, I think. Let me check. Requirements. Nice try, PHP. No requirements. Installation. Introduction. Is a Unix style? Yeah, so I think should be available on macOS. So since it's like Unix style, and macOS is somehow Unix, so only Windows can be implemented at the moment. So okay, so we have this pcntl fork, which returns us an int, which is like our process ID. So we need to have this process ID and call like this, let it be. So, and then call wait, let's use different color, and then call sysfd open on this file descriptor. So it's like, it would be like this too, like bypassing the, like, so it would be not our child. So what problems could be with this schema? So first of all, master worker can die, obviously. This is a problem, but not for us, only for master worker. So if the master process dies, all of the orphans like number 1, number 2, and number 3 orphans would be assigned to PID1. PID1. So PID1 becomes becomes a new father for these orphans. So and this is no problem for us, because we don't care about this. So since we just waiting for this FD open, waiting on like PIDs, and we are not the parent of this child, and we don't care who is the parent actually. So we don't care that master worker is the parent. We just need to reallocate it, like reallocate, and like start working. Continue like forking, continue sending signals to fork to this master worker. Then how we can actually stop? So, and this is a problem. This is we becomes to a problem. How we can stop the worker? In our previous, so we can kill it. So why not? But this is not the solution. The problem actually is that we should listen for the signals. Listen, and this would be in PHP part. Listing signal. So we should listen for our signals. So we should be able to send a signal to stop this worker gracefully, let's say. And currently we are doing the following, let's say, script like this. So we are how we stopping our workers nowadays. So first of all, we are trying to send an internal command called stop. Just could you please stop yourself? For the master worker, we just can kill it. So we are not. So since it's designed only to fork, we can easily just kill it. So without any problems, without any waits, and without any sorry to this master worker. But worker where user code is running, so we have to gracefully stop them. And we have this control internal command called stop command, and we should send through the relay this command. So could you please stop? And if it's not stopped gracefully, so we don't kill it. Goodbye. This is fairly easy to achieve, so we even don't need to change anything in this interface, because it's like relay here is interface, so we only need to change basically only worker. And you know, the main problem here is I did SOTP. Hello, Wolfie. How are you doing? Long time no see. I did SOTP. What is SOTP? Anthony, please. What is SOTP? So, okay, and we need to stop this. I mean, I did stop, maybe. So, like Supermind. So the problem here, it's not like basically not a problem actually, but how to achieve the non-zombie thing. So generally, if your worker dies without sending to this worker here, without sending this wait PID signal, in the parent, let's say this is a parent have process table entries. Process table. And this process table, it have like, for example, childs with like P2, 3, 4, 5, 6. And if this like worker with process with speed number 2 dies, it still be existed in this process parent process table, and it will become a zombie. So we will see like Z letter in your process table, in your like Linux htop, or anything, basically anything, any tool like who shows you processes. And yeah, this is a problem. How we can send to this worker, or if it would be like PID1, so PID1 will send this automatically, so no problem. But how we can basically send to this worker the signal with, please remove it. We can send sick child, wait PID, and I also tried all of these system calls to remove the entry, but who will handle this signal? And this is a big problem inside PHP, because you have to wait, you have to use wait PID. For example, we can try implement like wait PID, and it will be automatically send this system call to remove process entry. Or we can use also signal, it might be signal dispatch, or what, signal handler. So it should be some signal. So I think, let me double check. This some guy. Yeah, we can use pcntl with no hang, but the problem is with no hang we'll return immediately. So we should use like a loop inside to to have this thing working. And in previous implementations it was a problem also. So we have to invent something new to move forward in our memory consumption economy, Okay, let's create a branch. Let's call it, so I think I already have a branch for this. Stream worker, no, I don't. Only for the stream worker. I think I should have a pull request for this. Is closed. Yeah, for command support. Yeah. And this is like the final progress on this. Generics, Valerie, please stop. Okay, so this is our new fork worker factory. Oh yeah, so this is a test. I don't. Do we need updated allocator? So first of all, we need two commands. This command was introduced to fork, like to obtain a PID for a worker. So we don't need this stop worker. Oh yeah, so we do need this to stop a master worker. Yeah. And we should, so we also have to invent some kind of new pool, to, I don't know, to not to store this worker with all other workers, because this is not possible to send like general request to this worker, I mean master worker. And in this case we have to control it a little bit differently. I guess it would be, let's say, some kind of super small pool with one worker, We can do this, but pool have a big overhead of to store only one worker or not. So it's like yeah. So yeah, I have to split master from childs. This is for sure. We only need to send to the master. We only need to send a stop command to kill it, and just command to fork. So this is obvious. And yeah, so childs will be stored like a regular workers. So we don't need to change a mechanism of storing the workers. Yeah. Reset becomes very different. So reset becomes super like filtered, because it shouldn't reset a master worker. Yeah. I should not restart a master worker with reset, I think, because this will destroy all things related to op cache. I expect this. So I expect that if you restart the master process, yeah, so if it's like calling it. Okay, so let's start implementing this and see what will happen. So first of all, I need to have let me PHP worker, and I think I need to clone and replace. So how do I where is PHP worker actually? We need to. Yeah, okay, so this is not a problem to restart it. So I don't expect any, like, you know, any problems with restarting the master process. It's just so restarting the master process is fairly easy to achieve, because it's, you know, this is just our child and we can restart it without any problems. How can I replace PHP dependency? So I need to create a new branch. So let me copy something from our chat. Yeah, this is. Okay. So this is I need to fork PHP Gorge protocol, I think, and let me just paste it currently in the comment. So this is how it looks like. It was already implemented. So previously, so this is how it works. It's handle control. This is the control flag, and it's switched between two commands. So first of all, it's speed. So yeah, reconnect to pipes. Yeah, this is all of this code which we already did on like in the previous implementation. It will be supported only for the pipes, not for the all other protocols. Yeah, this is PHP. Unfortunately, Anthony, this is PHP. And I think I need to enable PC NTL fork. PC NTL, let me see. Do we have it for PHP 8.2? Yeah, we do have it. Let me compile it. Yeah, so, but I still need to, you know, I still need to use this repository. Where is it? Handle control. This is Gorge, or do we have it? We don't have this function anymore. Or where is it? I just mistyped the name. Yeah, this is handle control function. Should be here. Where is it? So it's not. This is inside the worker. Thank you for noting this, that the Gorge is just a protocol, but it previously was in this. Where is it? What is the name? What is this shit? So wait, this is branch number 3. This is for wait payload. Where is control frame handler? It's like, oh, it's here, I guess. What the fuck is going on? So it was previously, it was like super easy to understand what's happening. Wait for a second. So previously it was command PID, yeah? So, and oh my god, this is where is it? GitHub. So this is, I think, while true, okay, this is for payload. Yeah, this is the correct one. From frame and yeah. So this is has flag frame control. Yeah, so now I see that. Oh. I'm not sharing. I'm not sharing what? Okay, so you heard. So please stop. stop saying about PHP. I'm feeling a pain inside my like soul when I see PHP code. It's like super. It's okay. So okay. Emotions, calm down. If we have frame control, return save my control. Okay. Respect. Oh my god. My only god PHP. So why GitHub is break everything? Okay, guy. Okay. Make control. Okay. Yeah, now I see this. This is inside not handle control. This is make control nowadays. Yeah. So we should inject in this function. So in this function, we should have if not empty command stop. Previously was like if not empty command fork. Let me check. Where's my where's my terminal? So a few dependencies you need just to install this pcntl fork to have a fraction of our power. Oh my god, okay. So now, since we have all of this stuff, we need only to copy. I expect that we would have this new frame and all this, so everything changed here. So we don't have, we can't like send an exception. No, so it's like bool previously. A lot of changes here. Anthony, since you're on the stream, could you please do me a favor? Could you please create a branch and help me with the PHP part here while been working for the Golang? So basically what we need here to have, we only need to have a PID, because so after fork we would have two processes, two separate processes. And this is a way how we distinguish between our original process and the process created after fork. So the process after fork have to just return PID for us. And like original one should just return true. Yeah. So this is fun. So for PHP, this is kind of nothing to do, almost nothing, because it's only needed to create this part. But as far as I remember, the problem was that we have no options to reinstantiate a connection. So I think it was a problem with the connection of for the RPC stuff. Okay. Let's start from the Golang part. So okay, let's bring Anthony to the stream. Let me try one more time. Oh, I'm sorry. I turned off my microphone. Say something. 1, 2, 3. Once more time. I think no one hear you because I'm not seeing the sound is changing. Let me just reroute. Let me just reroute this. Output device, and it should go to music. Oh no, not music, but might be microphone.
I only have 15 minutes anyway, just so you know. 15.
This is the output of this is chat, okay? And the respect PHP, yeah. But let me. I'll edit in a minute. Audio capture device, Discord. Okay, and this would be GoXLR mini chat. Okay, now say something.
1, 2, 3, 4, 5, 6,
now
7.
Everything's fine. Okay, now everyone should hear you.
Wonderful.
Okay. Let's switch back. And where's your camera, Anton?
First, let me see. I don't know.
Now I see it. Let me.
Well, hopefully not eat myself, but okay.
So let me just. Once upon a time. So let me add this output audio capture device, Discord, and let me window capture Discord. Okay, Discord video. So fixing everything on the stream as usual. Stupid Linux, I'm sorry. So now you should be able. How can I do it not a full screen? Let me put it to screen number 2. Okay, so
I don't think I need to be that big.
Why not? You're big enough, so everyone will see you.
Okay.
Now let me see if it works if I switch a tab. Okay, it works, and now I need to bring. So the problem I currently trying to solve is
it's the fork process.
No, not the fork process. I need Discord video. Where is it? Let me. Wolfie G Discord. I think it should be this window. And oh, it's so small. Yeah, I get you. So I'm trying to. Okay, so let me just try. I'm trying to bring your video on a stream. So the problem. Okay.
That's fine. I have 10 minutes only. Let's just focus on a task.
Okay, so So everyone now see you. I think so with... Okay, so go on, Anthony. Help us, like fellow Rust
Well, I mean,
developers.
you obviously have to handle somehow the fork signal to, not fork signal, I mean the fork payload to the worker. So for that, you'll have to modify the payload
This is not a
factor.
problem, Anthony. This is already solved. So all
Oh, so
things related to the Golang are solved. Everything.
yeah, but it's not about Golang. I've been telling you about PHP part.
Oh.
Handle, not send, obviously.
Okay.
So you need to modify the payload factor and create new payload type for the command. Can you reveal PHP code here?
Do you mean like from PHP Worker? This?
Yeah, the one I sent you. Yeah, this
okay.
one.
Okay.
So like this is the where a worker handles that. So we will add a new case in here, similar to what you had before. Just case if payload. I'm not sure who wrote this code, honestly. I need to
We
talk
can
to this
see this
person.
with new feature blame, and let's see.
Blame.
Oh, who is like init repository C years ago? It's like you. You wrote this code.
No.
You can't fool GitHub. You can't fool GitHub.
What? I mean, you pointed me that I wrote the the curly brackets. The actual code is written by Alex. You can see that.
I think it's
Okay.
like a mix.
Maybe.
Yeah. So okay. So could you please edit?
You basically you need to do two parts. You want me to edit it, or you want me to tell you how to edit it?
No. I don't want to add something to PHP because I definitely will handle this in a few years. For me, it will be like too complicated task.
Just to make it work. So when you send the fork command, you'll need its ID, I think, right? Anyway, you need to go to payload factory from frame. So click on line 59.
Okay.
Yeah.
And what?
From frame. So yeah, you need to go to the implementation.
This one. From frame is this file. Search for the symbol.
That's something else.
I guess this is what we need. Public static function.
Yeah. So you'll need to train this, to teach this function how to create a new type of payload. If frame has flag, and then see the flag with self-make control, something like that. So which flag do you use?
We already have this, as you may see here, we already have somehow tested functionality here.
Okay, let's see. Fork,
it's like related to if we have like pcntl fork. So if not,
I see. Can you go to line self-make control just to see why they return in the can you scroll down in the PHP code? You basically have to see
on the right side or
on the right side, yes.
What line number?
Just make control. Okay, try command self-decode. Scroll down a bit.
Yeah.
If scroll down.
Oh, this is
that's what we have to do. We have to create a new class like fork and pass header in it, something like that.
Yeah.
So and for that you'll need to create a new class. So this is not something you can do if you don't know PHP.
I don't know PHP. And
okay.
I'm proud of this. Unfortunately, I can't do this. If you try to help me, like to create a branch.
Yeah, I'll just create your branch now.
So
can you paste me the code which you had earlier, so I can just immediately adapt it for? Okay.
Done. And let me just try to import this window capture, Discord video while you're implementing all the things.
Well, I'm not sure I'll be able to do it before I have to jump off, but I'll try.
Why I can't? So it definitely should be this pop out. Why it's not showing anything? Maybe we have like other options. So while you are helping me, why it's not connecting or not available for sure? Because you like, why you can't just share this window? Do we have other options?
Do you need to return any? Actually, let me just see your code. Do you need to return anything when you're forking?
I need
fork.
only for this fork, as you may see here, I need only the PID. So we only need new frame, which works exactly like this one.
Well, it's
So
easier to say than do, but okay.
So it just returns like integer to have a PID. So that's it. For me, it's like enough. And so I also needed to, I think, add something like percentile weight functions here. So I should be able to send and to remove this process not to be a zombie, you know. So we definitely need to think how to do this. This is Discord pop out, yeah. Discord pop out. Why are you so stupid and can be just captured by an OBS studio? So I need to practice this, I think. Make source visible. Where is the source? So I can understand. Okay, so let me check. So we have this. Oh, it shares basically htop. So it sees this htop. Okay, it's super cool. Properties for Discord video. it can share itself better. Spotify, terminal, but it can share pop-up. What if we do the following? Let's try this. If we try to return to the application and then move the entire application to this screen, and then do something like this. Window capture. Oh, we already have this Discord video. Discord, and then we can crop. Like, let's say 200. Crop left, nothing.
So to clarify, based on your code, when you send the fork signal to the process, your parent process would not respond, right? And only child will respond.
Yeah, so the initial process will just exit. So
Initial process. Well, what do you mean? Just exit. It's a master process.
Let me just.
Okay, I gave you the branch. I unfortunately have to jump off, but I gave you the branch in which I adopted the code you had earlier for
Oh,
for new
now.
package, so you can replace it. And this is a line I'm sending to you, which responsible for the forking.
This is still not be able. So why? Why it's so stupid on Linux? Why? Please stop. So I'll be able to crop your video, but it's not playing anymore. It just hangs. I have.
Can you actually hear me?
Yeah.
Okay. Sorry, I was just checking if my connection is still okay.
Yeah, you're okay.
Anyway, I send you the
Okay.
branch and the file, which you can take a look for. I have to jump off, unfortunately. Have another call.
Why? Why are you so mad, Anthony?
I'm not mad.
You're definitely
Disappointed.
mad. Because
Yeah.
you're just jumping out from the stream.
Yeah.
I have. Okay, so where is. Oh, feature forking. Okay. Let me just grab it to the stream. One commit ahead. Okay, so I get it. How can I now clone this? So it's not a problem to clone this branch. How can I replace? So as we see here, so I can just move it to the place where it was. How can I now inside PHP? I have these tests, yeah. And how can I replace inside this composer JSON? How can I replace the RoadRunner worker with my local branch? How can I do this? Anthony? Okay. Anthony just left us. Rest in peace, Anthony. So he left me in one-on-one in this PHP stuff. Okay. Okay, as usual. Let me check how to install this PCNTL. So Anthony brings us a good idea. And next time, I think we can join, I don't know. We can join just like some kind of other application to bring us together and see a video, because so this is a big problem inside Linux, especially for me, if you're trying to stream. So the problem is that you can't share the windows which are outside your workspace. So if the windows is outside your workspace, for example located at the workspace number 8 or number 1, not in the current one, number 2. So in this case, X11 or Xorg unmapping this window, and it becomes invisible because it's actually invisible for you. You know, it's actually invisible. There's nothing. I think only KDE Plasma supports the feature when you are outside of the workspace to share the windows from outside of the workspace. In all other cases, you are not able to, like, if you're like on a Linux, you're not able to actually, you know, share the other screens. And how we can solve this problem, and so I want to bring Anthony more often on our streams with like because it's just a fun, and this is very helpful for my empty PHP knowledge. So I have 3 displays just like just stored inside in my other room, but I don't have this arm which holds the screen. I'm going to buy this one and like have another display and share from this display all of the things. Okay, so let's go on. Let's go on with the Golang part, which we are like capable of updating. Git checkout. minus b and feature fork worker. And let's we don't need all of this. Oh, this is our Rust code. Thank you GoXLR, thank you NeoVim. Goodbye Windows Terminal. And this is why I thought about like switching to Windows, because because it's like all of the things works without any problems, so you don't need to buy an additional hardware, or you can use like a Riverside, I think. Riverside FM. Oh, Riverside FM. Sorry. So so I'm planning to have to bring Anthony on the streams, like to have this on the Riverside FM. So it would be like super cool, and it would be inside the browser. Actually, we can have a call inside the browser in Discord too. So, but yeah, it was like very unexpected. Okay. Let's create a new worker type. So do we need to... So first of all, we need to go to the IPC and pipe. And here in a pipe factory, we should also have a new mechanism of forking. Let me just check this previous feature implemented. Can we just bring this? Can we just like check out on this pull request? Unfortunately, I can't see the like a way to browse the just to. So as far as I remember, there were a button like called browse, and you will be able to browse these files like on the time where it was created, this branch, I mean. Review encode spaces. I don't need this. Okay, can we just let me see. PCNTL. By the way, PHP -m. PCNTL. We have this enabled by default. Yeah. Oh yeah, I remember. So I have an investigation about this. So almost everything, every PHP, like I don't know, PHP. I don't know, runtime, or what is this PHP server? I guess its runtime is have this PCNTL feature inside it on Linux. So I checked Ubuntu, I checked Fedora. So as you may see in Arch, it's also available. So we don't need to add additional packages as I tried to do this previously. So we don't need to do this. Okay, so we only need to start implementing this. cd projects temp and git clone https GitHub RoadRunner server and SDK. So I'm going to create a local copy and try to check out this. GitHub auth login https GitHub no Login is the browser. Please. Use GitHub Mobile. 66, good number. Should be done. Yeah. And could you please now check out on this pull request? Thank you. Oh. So there's no such remote. So I deleted this branch. So the only way to restore our knowledge is to... Oh yeah, so there's no such branch. Okay, the only way to restore our knowledge is to just copy all of this stuff. Fork. Control message, and this fork. Oh, this is like how it works, like fork process. Okay. Private function, but it doesn't return anything. Oh, send frame. Okay. Pid. Okay, frame control. Good. And we don't need to have if command is fork, and command is fork is checked by this. Okay, so I think I like restore my knowledge, which how I implemented all the things. Okay. Let's see. Do we need a worker actually here? Spawn with timer. This is inside internal protocol. Yeah, so we protocol, and we need to edit here, and what is the file? It's steel protocol, yeah. Okay, so and inside, oh yeah, so inside the protocol thing, we have several commands. So it's like a regular send command, send control, I'm sorry, and pid command. So they are designed to send different like control preparation mechanisms to worker to check that everything is fine currently. So because there are cases where you can just try to allocate a worker and worker dies immediately. So this is a problem for us because in this case we can made assumptions that we allocated a worker and provide a PID to the pool, like you can use this process, but process so we can provide a PID of a death process, you know, and this is like, you know, somehow a problem for us. And yeah, so okay. Oh, by the way, Meteor007, thanks for following and enjoy the stream. To get frame, put frame. Okay, so what is the difference of this fork command? Let me check. So get frame, relay receive, send control. If link PID is 0, we just return it 0, or returning a link PID. What is the link actually? A link is our PID command. We sent a fork command but received just a PID. Well, are you stupid? Just like created this? Why? What reason this payload was created? Okay, let's see. Might be it will be used like a little bit later. Yeah, we also need to. Yeah, this is like generics, like powerful generics. Worker process. Yeah, this is the main building block of the fork. This is our fork worker command. This is inside the socket factory. Why it's inside the socket factory? What? I think this is some misunderstanding between me now and me past. So it shouldn't be inside socket factory, because socket factory is designed to work over TCP or over Unix sockets, you know. And this is a problem for us because why it's inside socket factory? Echo Unix. No. No. Me past wasn't correct in this particular decision, because this thing should be implemented only and specifically for the pipes. We shouldn't touch existing mechanisms of allocating, you know, of working through the Unix sockets or TCP, because it will lead to allocate the second resource, so everything will be copied. You know, if you fork already existing connection, it will be forked. So we don't want to fork the existing connection. We only need to fork like just pipe, so and close, and yeah, we can close existing pipes to not, you know. Oh, maybe that's a reason. So we need to. We don't have close a pipe PHP. I got pros close. Oh, we have a resource. So why it's important? So if we fork, let me just paint this. I do like to paint. So if we have the process, yeah, we have PID1. This is I think it's std in, stdr. I'm sorry, std out, and stdr. So when we fork process, when we create a fork, all our file descriptors will be also forked into new process, but will be associated with the previous one. We don't need to do this. I think that we need to close these ones, but if we close them, oh yeah, so this is a problem. If we close the existing one, so we won't be able to send a preloads anymore, so we only need to dedup them. Dedup process fds. So we have a dup, a duplicate and open file descriptor, but do we have a dedup? Something like this. F control. And I think that was a problem with implementing this feature on the pipes. I should find a way. I should find a way of implementing this on pipes. So, okay, let's just think. We have a process. We duplicated a file descriptors on it. So all methods I know requires a lot of work. It's not a lot of work, but it's a lot of work in PHP, you know. So so the problem is that so on the forked process, we're going to send to forked process pipes. We have to send the data into the forked process pipe, not on the original one. But while they would be copied like this, if they would be copied, so associated with, like, you know, with a, let me just write to understand it better. So we have a master worker, yeah, and we have, let's say, file descriptor, only one file descriptor. Then we fork this file descriptor. I'm sorry, fork this process. And this becomes this one, master worker, yeah. But it also forks a file descriptor as well. How can I feel it? It's interesting. How can I use this as a background? I think. Okay. I think it's not our case. So yeah, it would be FD, but it will be associated with this one. So all the data we send or we receive through the like original one would be sent to the like forked. Let me check this. What would be with the file descriptor on fork? File descriptor and fork. Good article. It inherits a copy of the file. Yeah, so closing the descriptor in the child will close it for the child, but not the parent, and the vice versa. Yeah, this is correct. This is what we already know. But the problem actually is that, okay, we close it in the like. So yeah, okay. If we close, we should not close it in any way, nor for master nor for child. Right into the same file. Yeah, the kernel schedules the process independently, so you get in relevant data in the file. Yeah. However, POSIX, to which Nix largely is completely conforms, stipulates that read and write functions from the C API are atomic with respect to each other when they. Yeah, so they respect each other, but not the data which we send. So I don't want. So I do want to send the data specifically to the child of the, but not for the parent. Okay, ChatGPT, it's time to shine. Time to shine. So I'm using ChatGPT very rare, but it's time to ask about the like article or a book or something. Let me just check this. How to make it dark? Yeah, like this. Okay, ChatGPT. What will happen with the process on fork? Come on. Yeah, I just want to bring into context ChatGPT to ask you know, a real question about file descriptors. The child process inherit a copy of that process. Yeah. From this point, that the process can execute different code parts and operate independently with each. Okay, let's prepare. What? Do them. Do the parent receive the data sent to the child's std in? Wait for a second. Any input written to the child's std in will only be read by the child process, and any output written to the child std out or std will only to the parent process if it explicitly read from this. Oh. I do not trust ChatGPT in this assumption. I guess I need to Linux programming interface. I think I should have this book. Let me check. I forgot to install my library. So everyone who wanted to learn about Linux, I highly recommend to buy this book. So this is like a holy Bible for like Christians, but for us, for the Linux belovers, you know. Calibri. Could you please be slightly darker? Okay, Linux programming interface. And here we are. And let's search about a fork. Okay, I think is viable. Fork. The fork allows one process to create new process. Okay, we know this. Wait state of system call has two purposes. Wait suspend the execution. Yeah, we know this. Execve. Basically we use execve for inside Golang to fork the PHP CLI processes. Some other operating systems don't care about other operating systems. Oh yeah, sick child. This is kind of important because sick child also is designed to remove from the parent file process table, as I mentioned before, to remove this to remove a process state to not become a zombie, as I mentioned before. So this is basically diagram how it works. So on exit it's just called sick child, and if it like attached to Ep.1, if it like orphan. Creating a new process fork. Super. So I know. Okay, error limit. Oh yeah, by the way, in the recent Golang versions, so error limit sets to maximum number, so available in the system automatically. So you don't need to somehow use ulimit to set number of file descriptors to some number. User sleep. Okay, t fork. Yeah, and this is how basically to distinguish between two processes, because when you are working in some kind of high-level language and creating a thread, you should definitely think that thread is not the same as the process. So obviously, and previously the only way to create a new execution unit of execution, let's say, is to create a fork of the existing process, and the way to distinguish between them. What's this -1, 0, or default? Like default is like all other states. So if it's like give child a chance to execute. So if it's like -1, that it like in all Linux returning things, this is describes an error. So some kind of error happened. So 0, as far as I remember, is original process. Oh no. So 0 is a child, and all other numbers, especially 1. So this is for the parent. So here program executes is the following. So we are creating a fork. If -1, we are just returning an error. So 0, we are trying to execute some ID data multiplication. And here in the parent, we just waiting 3 seconds. So giving a chance to the child process to be executed actually, and to print this message to the std error. Oh yeah, and this is what we need: file sharing between the parent and the child. When fork is performed, the child receives duplicates of all the parent's file descriptors. So yeah, these duplicates are made in the manner of dupe, which means that corresponding descriptors in the parent and the child refer to the same open file description. So, and this is what I'm worrying about when I'm using pcntl fork on a pipes. So that we'll use incorrect pipe. As we saw in section 5.4, the open file description says the current file offset. Yeah, so all of these are just offsets. So it's just offsets. So all these file descriptors, I mean, so just offsets of process memory. This flags to show. Consequently, these attributes of an open file are shared between the parent and child. For example, if the child updates the file offset, this change is visible through the corresponding descriptor in the parent. We are not planning to somehow modify the code. I mean, somehow change the file descriptors, close them, or do something inside the PHP, do something scary. The fact that this attribute should be found default is demonstrated by the Linux program listing in 24.2. Is there a way to compile this program? Can you just GCC? Okay, so fork file sharing, file offset before fork, or append as child has exited. Set buffer. Oh, we also disable. Oh, yeah, this is a command. Disabling buffer. Make temp. FCNTL means like file control. FCNTL file control, and so through the FCNTL or all of these control attributes, we can apply a lot of attributes on a process. For example, the very useful technique to apply non-blocking weight on a network sockets. So usually almost every programming language, including Go, blocks on reading from a network socket. So this is like somehow default behavior. And the main thing here is, in some cases, I don't want to wait. So I just need to check if socket returns an error, then it blocks. But if it contains some data, I can like read the data until it blocks. But I don't want to block. I don't want to read the data and exit. So, and this case is, so all of these cases are inside the RoadRunner. All of this like code from the from this book, a lot of techniques like have a counterpart in our in the RoadRunner. I think it should be in the frame. Yeah, no, not in the frame. I think it should be in internal, I guess. Yeah, this is the case. So imagine you have an error in your network socket. Yeah. So by error, I mean, so you expect some data to read from network socket, but by some reasons, the data might be different. So might be some trash. And here we expect to see our frame, our like special structure, special protocol, which Anton mentioned. It's Gorich. So and we don't want to. If we see a trash inside a socket, we rather close it than like just. Instead of just like just trying to like restore a state, restore a frame, etc., we just close it, so without any problems. And the major problem here is if we receive a garbage from it, we should not block on reading because we don't know how much data to read. So, and in this case, we are reading only the data, and if you block, we just waiting for 2 seconds and kill the process, and that's it. So, and in this case, it would be super useful to have some kind of FCNTL system call. We can introduce it through unsafe and apply it, but it won't be cross-platform. And but this code supports also in Windows, and yeah, this would be a big problem. Okay. Case fork, F control, yeah. So sharing open file attributes between the parent and child is frequently useful. For example, if the parent and child are both writing to a file, Sharing the file offset ensures that the two processes don't overwrite each other's output. It doesn't, however, prevent the output of the two processes from being randomly intermingled. So yeah, this is the problem. And this, if this is not desired, then some form of process synchronization is required. Yeah. For example, the parent can use the wait system call to pause until the child has exited. Yeah, so we'll also, so it's like a common technique. If sharing of file descriptor is in manner not okay. Parent file descriptors entry. Yeah, so in this case, basically, what does it mean? It just writing into same file from the two processes. We are not going to do this. We only need to write to a process, not from a process. From a process, we can read without any problems from specific PID. Copies, yeah. So memory semantic is good. Yeah, this is what I mentioned at the beginning of the stream. Copy on write. I mean, this copy on write. So for the pages in the data heap and stack segments of the parent process, the kernel employs a technique known as copy on write. So this is very famous technique, basically. The implementation of copy on write is initially the kernel sets things up that the page table entries for these segments refer to the same physical memory pages as the corresponding page tables entries in the parent, and the pages themselves are marked read-only. So this is very important to understand. So all of these pages which we created previously here, like on the previous process, becomes read-only. And if someone tries to write into it, so let's read, yeah. Physical memory enters read-only. After the fork, the kernel traps specifies a trap for a system call, for example, for read or write, and if it becomes into trap, it becomes to trap handle, and trap handle then navigates it to the a memory segment where it can write. Traps any attempt by either the parent or the child to modify one of these pages and makes a duplicate copy of the about to be modified page. Yeah, this is very important to understand. This new page copy is assigned to the faulting process, and the corresponding page table entry for the child is adjusted appropriately. From this point on, the parent and child can each modify their private copies of the page without the changes being visible to each other process. So this table illustrates how it works actually. So so unused page frames, yeah, and yeah, after modification. So as you may see here, both of them tries to write into the frame 1998. Good year, I guess. So then it becomes like frame 2038 and frame 1998. So how it works basically. This is good technique, and because of this technique, we are going to save a memory. Save a memory. Memory footprint, controlling the process memory footprint. Yeah, so the U fork. Okay, so I guess I think I need to try the new. I need just to try to work with the pipes relay, not with the socket relay, which was previously done. And I'm going to copy all of this fork functionality. Oh, I already copied it. Fork already copied, and where is test configuration? We are going to busy ourselves a little bit later with this new process of new forked worker allocator. Yeah, so we also need to update our allocator. So I will show you what does it mean. It's inside the pool. So what does it mean? So process, we have allocators, like all modern languages have, like, you know, Rust can provide an allocator to vector, but we also wanted to have this fancy way to provide our users to like allocate the processes how they want. Actually, you know, that is kind of interesting because no one ever tried to update this code, but understanding the architecture like to predict the architecture in the future was a good vision, especially for this kind of subsystem for me, that I expected that we would have different type of allocators. So, and pool is independent of allocators. It just calls the allocator to provide a worker to it. So, and that's it for pool. And we can modify our factory, like as you may see here, forked worker allocator. What's the difference? Spawn worker with timeout. I think they are the same, but spawn worker with timeout means in our case slightly different context. I guess this would be our not spawn worker with timeout, it would be like spawn forked worker. We are going to update this. So, and we can like having good abstractions layers, you know, even in some library code which, you know, used only as a binary. We can easily add new allocator here. And yeah, we are going to, so I'm going to update this spawn worker with timeout and to have factory, I guess, just spawn forked worker, something like this. Okay, so this is also the old command here. Fork worker, oh yeah, fork pool, yeah. So this is interesting because this is new type of pool. And this pool is specifically designed to be used inside for the master worker, as I mentioned before. So this is, we would have slight overhead of using it, but yeah, you know, so this is kind of useful. Okay, guys, so I guess that's it for today. So I think we understand a good thing today, that we will try tomorrow for sure to implement this forked worker allocator on a worker. I also asked Anton before the stream to like update and provide a way to replace the composer JSON with a new dependency, because I actually don't know how to do this. I'm not a PHP guy, so I should found a way how to do this. I'll ask Anton out of the stream, and maybe tomorrow I'll ask Anton also to join us, and I'll be slightly better prepared for this event, and I'll try to configure you know, Discord and everything. So yeah, okay guys, thanks for being with me, and have a good evening, and see you tomorrow evening as usual. Bye bye.